Hi, I'm Carlos Martinez, founder and CEO here at Sipping Blogs. Today, I have the privilege of interviewing one of the top authorities in the country when it comes to data science and data analytics, Dr. Jennifer Priestley. She's here at KSU, and we're going to get her perspective on this subject when it comes to education, skills, and the employment. But we're going to focus on her book, Closing the Analytics Talent Gap. Dr. Jennifer Priestley.
Yes, hi.
Thank you so much for joining me this morning.
Absolutely, my pleasure.
You are a distinguished and recognized leader in the field of data science and data analytics. It is an honor to have you today and give us an interview about your book, which is super exciting. Closing the Analytics Talent Gap, the Executive's Guide to Working with Universities. You and I could sit for hours and hours and talk about this topic, which we love. But we're going to focus on a few things today, and I really want to pick your brain so we would like our audience to get some of your knowledge and how successful you've been developing the program at Kennesaw State University. So the way we're going to form this interview will be, first we're going to talk about the education, the formation of the education, drive that into the skills, and then talk about employment as a whole, okay? But first of all, can you tell us a little bit about the book and how that came about?
Oh, absolutely. So the seeds of this book actually were probably sown close to a decade ago. My co-author, Robert McGrath from the University of New Hampshire, and I first started working together in, 2014 maybe, and he and I were just having some hallway conversation around some of our pain points and some of our struggles. We were both involved in starting up analytics programs at our respective universities. So he was at the University of New Hampshire, which is about 1,500 miles north of Kennesaw, Georgia. And yet we were having basically the same conversations. We were experiencing, again, the same pain points, the same challenges, and the same issues. So sort of in no specific order, on the education side, we were both experiencing this intersection of drawing faculty from statistics, from mathematics, from computer science, all coming together to try to form this new thing called a program in data science, a program in advanced analytics. We were also working closely with the business school, working closely with the Department of Health and Human Services at the university, with engineering, with all the different kind of constituent departments at the university. But we were also finding ourselves working with the private sector. And we were reaching out to the private sector to bring real world questions, real world challenges, and most importantly, real world data into the classroom, and how you start those conversations and how you reach out to companies, how you explain what you're trying to do with data science in an academic environment. And so he and I were sort of sharing common war stories. And as we were having these conversations, we said, gosh, we should write a book about what we're doing. And that really became the genesis now of our book. So thank you so much for asking the question.
Yeah, no, so because that's one of the things that, we're in the field of data science, data analytics, and it's always difficult to identify who's a good candidate for a specific job. Data science is a field that can be interpreted in many different ways, right? If you're looking for talent, so like I actually pulled some data from Sipping Blogs to look at what are the most common education backgrounds for someone with the title data scientist, right? The top ones were computer science, mathematics, data science, and data analytics as a whole. But then you have people in physics, electrical engineering, psychology, engineering economics. I mean, there's a broad range. So when the program is initiated, or as people are looking at where do you find this talent, what kind of education background you get people through these programs, how does that work? How do you make those decisions about the program itself?
Yeah, great questions. So I think what you've really highlighted is the issues that are happening within academia are actually very much a parallel and a mirror with some of the issues and the challenges that are happening in the private sector. How do we characterize what a data scientist actually is? And I think your points here are excellent, right? Somebody could have a degree in physics and call themselves a data scientist, but similarly, someone could have a degree in psychology and call themselves a data scientist. So we could have kind of a broader conversation around kind of what that means. I do take issue with the people who, you see them on LinkedIn, right? And it's like on Friday, they're a poet, and then they take a boot camp in Python over the weekend, and then they change their profile to be a data scientist on Monday. So I take a little bit of issue with that, but I do think that that we have seen this evolution of data science as an academic discipline that has emerged roughly in, we'll call it two types of programs. So I'll refer to those as hub programs and spoke programs. So the hub programs are programs where somebody is truly studying to become a scientist of data. They are truly, we'll call it application agnostic, and they're truly learning how to extract, transport, load, clean, model, and interpret analytical output. They understand how to work with data across that entire continuum. And these are the students who are in what I'll call hub programs. So these are students that are going to be more closely aligned with computer science and mathematics and statistics, and then true data science programs. And then they'll have some area of application. So, a theoretical data scientist doesn't really make sense. So you'll have somebody who's truly studying the science of data, and then they may pick up an application in finance, or they may pick up courses in marketing, or they may pick up courses aligned with healthcare, with biology. And so those are students that are scientists of data. They've studied a hub program in data science, and then they have some area of application. But then there are great programs out there that I'll call spoke-based programs. And this is where you start to see people that have like degrees in psychology or degrees in marketing or degrees in finance, but they're still calling themselves a data scientist. So they may have majored in psychology or majored in finance or marketing, but then they took a spoke or a concentration or a minor in data science or analytics. And so they picked up some series of courses that allowed them to learn how to analyze data in their discipline. So they're not truly a scientist of data, but they picked up some basic understanding of how to interpret data, maybe how to do some nominal programming. They're probably more going to be aligned with the point and click type software if they're in kind of a spoke-based program. And so neither of those models is necessarily better or worse. They're just different. And so I think that where we start to see challenges and problems in the marketplace is number one, with the students and with the academic institution, ensuring that the student understands what their experiences are, such that they understand where they're going to add the most value in the marketplace, right? So if you're coming out of a hub-based program, if you're coming out of a program that's gone deep into the science of data, then you're going to be much more capable of actually writing the algorithms, right? You're going to be deeper in the math, you're going to be deeper in the programming, but you may not necessarily have some of the nuances or some of the vocabulary that's going to be specific to healthcare, specific to finance, or specific to marketing. And you may not necessarily have all those skills with translating that data into information in that discipline. And that's okay, but let's just be honest about where the strengths and the weaknesses are. Similarly, if you're coming out of a spoke-based program, if you're an MBA student and you took one class in analytics, that's fine, but let's just be very honest about what your skill set looks like. So you may have some very strong business acumen, you may have some very strong understanding of the nuances of the vocabulary in finance and marketing, you may be able to work in a point-and-click environment, and you may be able to translate those results into whatever the original business problem was, but you probably are not nearly as strong in your ability to go inside that black box, right, and actually write the algorithms and do the math and actually do the programming. So again, neither one of those approaches is wrong. I think we just need to be very honest about where our skills are fitting within that continuum of data science.
So is it fair, well, because one of the things that I guess as an employer would struggle with is identifying what is a data scientist, right? And people like to use it these days. If you are good with Excel and you use large spreadsheets, and some people will say, they put on the LinkedIn and say, I'm a data scientist, or they take the bootcamp. Right. But is it, do you have an opinion on when is it appropriate for someone to say, I'm a data scientist, or is it, because you have to be honest with yourself, but a lot of times I run into people, they're not data scientists, they might be good business analysts, or they might be good data visualization engineers, but they're not necessarily people that can write the algorithms and then go to the core. However, you'll see that in one of your last interviews, or you guys were doing a conference, and I saw that one of the top skills that was sought after from data scientists was communications. I don't know if you remember that one.
Right, yeah.
Which is interesting now, because now you're kind of forcing those people that write the algorithms to have great communication skills so they can articulate the findings, right? And the more predictive type of things that are the outcomes of this algorithm. So how do you balance that? What is a data scientist? How do you, who's allowed to call themselves a data scientist? What's your opinion on that?
Right. Oh, it's such a great question. So I think, again, we need to have a very honest conversation within the industry around data science. My opinion is that we've got people who are scientists of data, right? Who I think truly have that moniker of data scientist. And then we have people who have some skills in analytics, right? So I think that the industry and the conversation is starting to bifurcate a little bit in terms of analytics and data science. Data scientists are the ones, again, that are going to be much deeper in their ability to write the algorithms, do the math, actually go inside the black box, versus analysts, people who are taking analytics classes, which tend to be more spoke-based programs, right? So they're going to be a marketing major, an MBA student, and they're going to pick up one class in analytics. The study that you were making reference to, I have to do a shout out to 3 of my colleagues, Gautam Chakraborty at Oklahoma State, to Jeff Cam at Wake Forest, and Missy Bowers at the University of Tennessee. They actually wrote a brilliant paper that was published through Informs that looked at tens of thousands of job ads and trying to understand, again, what is it that people are looking for in a data scientist? And you're right, the kind of the most common skill, no matter what the job ad, the most common skill was communications. And I think communications here can take a couple different forms. I mean, yes, it's communications with the client, right? Being able to take a very complex, very technical, very deep algorithm and be able to explain that to a client in kind of non-technical terms. There's no question that that's an important skill, but it's also internal communications. It's being able to work within your own environment. It's being able to explain to the marketing team or to the finance team or to the CEO or to whomever the internal customers are, being able to explain to them what you've done. We tell our doctoral students all the time, you can go super deep in your ability to write these algorithms from scratch, but if you can't explain to somebody what you've done, if you can't explain to somebody why what you've done is relevant to what they're trying to accomplish, then it really kind of begs the question, what value are you creating? So yes, so communications is definitely a high priority skill, whether you are a data scientist, truly a scientist of data, or if you've picked up one analytics class. But I want to highlight that communication takes a lot of different forms. Communicating internally with your internal customers, and then communicating externally. So you have to be able to communicate to both highly technical audiences as well as non-technical audiences. But yeah, absolutely.
Yeah, so in the other point, so now we talk about communication being one of the key skills, right? But then if we move more into the technical skills, I get a lot of questions. People say, hey, I want to start coding, right? I don't know anything, but I know that data science is hot and I want to start from scratch. A lot of universities want to start programs associated with data science. Right. So if we look more at the technical side, there are some again, data science, you can go from all the tools and all the different coding methodologies, and then you have image recognition, you have natural language processing. It's so broad, and it can go to the statistics. So from all of that, what would be the core thing that you think to develop a program would be a good way to start thinking about developing a data science and analytics program?
Sure. So again, I'm all about honesty and transparency, right? So it's always, you have to be very clear on what problem you're trying to solve. What what part of the employment gap, talent gap, right, are you trying to close? If you're trying to go deep, right, into truly learning, training people to become scientists of data, then that type of program is going to need to be very closely affiliated with statistics and computer science. And those programs probably need to be housed in a college of computing, or they need to be housed in engineering, or they need to be housed in science, mathematics, with some area of application, right? Alternatively, if you're really trying to go into more of the consulting side, more of the side that is going to be taking the results and translating it back into the context of the original business problem, the analytics programs, those tend to be much more closely affiliated with business schools, where those students, again, are picking up 1 or 2 classes in analytics. I think where programs get into trouble is when they try to do all things for all people, and they end up going very broad and very thin. If I could give anybody a piece of unsolicited advice, which my colleagues will probably tell you I'm full of unsolicited advice, is I would say, pick a side and then go deep, versus trying to do everything and going very shallow.
I love that, because you can't do everything. You will not succeed. About you focus, picking a lane, being really good at it, and then evolving from there, right? If you want to start with even a business analytics or a statistics program, that can potentially evolve into something else. I think that's key.
Absolutely.
Now,
actually, can I add
Sure.
to that briefly? So I now have been in academia close to 20 years after having spent 11 years in the private sector. So I started working when I was 6. No, not really. But now, having been in academia for quite a while and having taught students from less quantitative backgrounds, how to engage in statistics and computer science, and taking students from like statistics and computer science and trying to teach them kind of the business acumen and how to do presentations and how to communicate. I can tell you that it's easier to start with the hardcore quantitative skills, and then build into the communication and into the business acumen, build into those areas of application, than to try to take somebody who is much stronger in the business acumen side, who has been involved in problem solving and management and maybe thinking bigger picture, and then trying to teach them to go deeper into the programming and into the math. That's a lot harder. Not that it can't be done, but I do find it easier to take these highly quantitative students and really ensure that they understand the importance of communication, the importance of translating the results into information, and learning how to communicate to a non-technical audience. It's easier to go from here this way than to start here and go this way.
so I guess if you start here and go this way, it might be more superficial, right? What you learn, which is that's where you come into learning Python, or learning how to use a technology that can help you solve a very specific problem for that specific discipline. Mm-hmm. But it will be harder for you to actually become a full data scientist, right? Just because it will take a lot longer.
Right, and then I think you also have that misalignment of expectations, right? That's the person that took the one boot camp over the weekend, and then they want to claim that they're a data scientist, and then they can't figure out why they can't get the job. Let's just be honest about what your skills are and what your skills aren't, right, on both sides. And part of this is being challenged by the fact that, unlike the law, or unlike medicine, unlike even engineering, we don't have a certification body in data science, right? There's no third-party central agency that certifies if you're a data scientist. And so I think that's muddying the waters a little bit too. I like the CAP, the Certified Analytics Professional exam, that credential that is offered through Informs. I think that's helpful, but that credential doesn't test anything having to do with your quantitative skills, right? It really is more about how you think about a problem and how you identify what the right tool is and how you identify, again, how to translate a result back into a business question that ultimately is going to add value to whoever your client is. So I like the CAP credential. I think it's the right start, but the only caveat to that is it doesn't test on those really strong quantitative skills, which I think are so critical to data science.
So recently, you and I had a conversation, and you said something really interesting that you heard in a conference, which said, or someone said, if we place the students in the private sector, we fail. What does that mean?
Yes. So funny. So the context here is that I was at a meeting with Robert McGrath from the University of New Hampshire. We were both at the meeting of analytics program directors, which is sponsored by Informs, great organization. The meeting of analytics program directors literally is what it says it is. It includes about 100 people like me from all across the country who are academics, who are the directors of analytics programs. And you have, massive universities there with tens of thousands of students, all the way down to, kind of smaller, maybe even junior colleges. So you get the whole range, right? Highly ranked schools, schools that are coming up the ladder, across the continuum. And so we were part of a meeting where we had somebody from the private sector who was speaking, and she had a PhD, but she worked in a private sector organization, and she's talking about all of the work that she does as a sort of a research scientist in data science at her organization. And then we came into the Q&A section of the talk. So again, this is an audience of about 100 academics. And this particular individual stands up and says, almost verbatim, if we are placing graduates of doctoral programs in data science in the private sector, then we have failed. I'll pause while we all reflect on that statement for a minute.
I paused when you said that first time.
Yes. So there was this, it was like a record where you, for people that remember records, where you scratch the needle, right, across it, and everybody just stopped. And it was interesting because about half the audience gasped and kind of giggled, and about half the audience just kind of nodded, like, yeah, that's true, you're exactly right. And you might say, well, how could somebody say something like that? So historically, universities, as they graduate people who have earned a PhD, those PhDs then go into academia. That's just how things worked. So forever, when you finished a PhD, you would join a university, you would get a tenure track position, you would become an assistant professor, you would publish, you would earn tenure, you would become an associate professor, and then eventually you would become a full professor, and then you died. And that used to be the career path for academics. That used to be the career path if you chose to pursue a PhD. Around 2017, I would argue in part because of data science, around 2017, we saw more people earning a PhD in a STEM-based field going into the private sector than going into academia. So think about that for a minute. In 2017, we saw for the first time more people who earned a PhD in a STEM-based discipline going into the private sector versus going into academia. So why is that? Why are we starting to see that shift? Well, I think part of the reason is no doubt because of the challenges that organizations are faced with related to this new normal with data science, right? The new types of data that we're working with. Data doesn't come in nice rows and columns anymore. Data is massive and unstructured and streaming. How do you translate voice? How do you translate images? How do you translate text? How do you use that to inform decision making, right? How do you translate that into data? The methods and the techniques and the math that's underpinning all this, how you take this massive amount of structured and unstructured data and translate it into meaningful information to solve problems. So there's no question that part of that is what's driving the number of PhDs that are going into the private sector. But I think also, again, historically, if you were going to do meaningful research, if you were going to engage in meaningful publications, you had to do it through an academic affiliation. Well, again, Dr. McGrath and I wrote a paper in 2016, 2017, where we found that about a quarter of the people who were an author of an academic publication actually had no academic affiliation. They were part of Google, or they were part of Amazon, or they were part of PayPal. They had no academic affiliation, but that doesn't mean that they weren't engaged in meaningful, thoughtful, relevant research that was contributing to the discipline. So I think this kind of turning research and meaningful contributions kind of on its head. You don't have to do that exclusively within the context of an academic environment anymore. You had mentioned Equifax earlier. Equifax has, dare I say, hundreds of PhDs who are working in their organization. They are engaged in incredible research that is making relevant, highly valuable contributions to the data science community, as is, certainly Google. Google is a massive employer of PhDs. Amazon has now become a regular sponsor of research with the National Science Foundation. We never used to see things like this prior to 2015, 2016. So I think this idea that if we only place students, we have to place students of PhD programs into academia. I mean, it's such a dated, such an outdated, dare I say, irrelevant perspective. You can graduate students out of doctoral programs and place them into the private sector, and they can go on to do amazing things, not only contributing to the way we think about data science, but contributing meaningful research that ultimately is making a difference.
Yeah, the interesting part is why do they still think that way? Maybe they haven't had no exposure to the private sector, or they haven't seen the impact there, because I just don't understand that point of view, and I would like to see why we would see it that way. And it traditionally has been that way, but how do you still see it? Even if you're doing research, the more you do, the more you see how things are changing and how it's evolving.
Well, I think with every passing year, those opinions are increasingly in the minority. As we see this membrane between academia and the private sector continuing to become increasingly more permeable, right? And increasingly placing more people out of doctoral programs into the private sector, and having people from the private sector come into academia. Again, this membrane used to be very, very tight, but it's increasingly becoming very permeable. So hopefully that opinion is not only becoming one of a minority, but also eventually phasing out.
So I'm going to move to talk about employment, but I do want to hit on one quote that I one of your articles about the book, which is the challenge of building the curriculum for the program, right? Because could potentially be all over the place on how you develop it, could be a big mess, right? So I saw your quote. It is actually from Audubon Bismarck, and says, if you like laws and sausages, you should never watch how either one is being made, right? So when you wrote that, what were your thoughts on it? Was the one about the curriculum or data science as a whole? Because it's the same thing, right? It's a big mess, and you have to organize it, and it looks good at the end, but how it's being made, you kind of freak out.
Yeah, right. So that quote is really timeless. It can be applied in so many different ways. If you don't like, you should never watch laws and sausages being made. You should never watch a data science curriculum being made. So I think. I think the challenge there in terms of developing a data science curriculum, so let me take a step back. So we at Kennesaw State, we were the first university in the country to launch a PhD program in data science. And so we didn't have any best practices to choose from, right? It's not like we could go scan all the universities across the United States and kind of pick and choose what we wanted. We started with a blank piece of paper, which is absolutely the most terrifying thing to do, right? Is to start from scratch. Provided an incredible opportunity, but was terrifying at the same time. We started looking at, again, kind of what we were doing in statistics and what we were doing in computer science. But ultimately, we brought in faculty from really all over campus to help us start to think through this. We brought in some faculty from the business school, and we brought in, again, faculty from statistics and computer science and mathematics. We also brought in some faculty from the humanities. But more importantly, we reached out to the business community, right? We went out and we talked to the big employers in the metropolitan area of Atlanta, and we brought them in and we brought them around the table. And I would be lying if I said that we met one time and we had a very clear list of what we needed to be teaching in the classroom. It was a very long, arduous process. And if we had kept everybody's ideas, then it would have taken 15 years to have gotten through that PhD program. So we had to kind of pick and choose and pare back. And ultimately where we landed is we have 2 required math classes, 2 required PhD level classes in mathematics. We have 2 required PhD level classes in statistics. We have 2 PhD level classes that we require in computer science. And then the student has to have some declared area of application. And again, that could be healthcare, that could be finance marketing, that could be statistics, that could be engineering. We have a wide range of areas that our students are ultimately studying data science. But it was not a clear linear path where we sat around the table and we said, yep, here's the list of things that we're going to teach. Let's write those down and let's submit it. That was unfortunately not how it worked.
But you hit on a great point, because actually it was leading to my next question. One of the reasons first I reached out to you, because you have been able to connect with some of the top employers here in Atlanta, right? So I'm an Equifax alumni. That's how I learned about the first time about the program at Kennesaw, because we had great people from Kennesaw working in our team at Equifax. But how you develop those relationships, and how and what I'm hearing is you actually while you were developing the program, you weren't just saying, hey, we have these graduates here, give them jobs. Right. You actually reached out to them, figured out what was the business need in terms of data science analytics from that side, right. And that helped you start coordinating the program and how you built it, right? So it wasn't something you did after, it's something you did during the process. Absolutely. To develop the relationships with
Absolutely.
employers.
From the beginning, we had representatives from some of the biggest organizations across the metropolitan Atlanta area, and so that certainly included Equifax. They have always been an important partner at Kennesaw State. We brought in the Home Depot, and we brought in AT&T. At the time, we brought in SunTrust Bank, which is now Truist Bank, and we brought in Coca-Cola and some of the other big employers across the area. And we said, bring us your job ads, bring us your hiring needs. Help us understand, as Wayne Gretzky used to say, the reason I'm the greatest is because I skate to where the puck's going, right? Not to where the puck is. Right. And so from an employment standpoint, we want to understand, where is the puck going? Where are the needs of the metropolitan Atlanta employers? Where are your needs going? And that really informed how we built our data science curriculum at Kennesaw State.
And so with that, right, now that you have students going out, so you have built this relationship with these employers, right? And I think you guys are being effective at placing them because they trust you. And then in terms of now, when you have the students going out, how do you help this, or how do you position the students in the marketplace? So what I mean is, how does a recruiter find this talent, right? Because we talked about the challenge. Are they looking for the computer science major that knows Python and Spark and TensorFlow, or right. How should they find this talent in the marketplace outside of those employers that you guys work with? Yeah,
great question. So I would start by saying data science now has evolved into a 3-tiered major. right? So we have students at the undergraduate level, the graduate level, the master's level, and then the PhD level. And so I think it very much depends upon what the needs are of the organization in terms of how they reach out to the university. Certainly at the PhD level and at the master's level, and I think this is going to be true of most universities, is that a program director of a PhD program or a program director of a master's level is really a full-time job. And so there will be somebody who is identified on the website as the program director for the Masters of Science in Data Science or the Masters of Science in Applied Statistics and Analytics or Masters of Science in Analytics, whatever the program is. That is a full-time job. And so I would encourage employers to identify who that person is. At the undergraduate level, there might be a program director. You might want to reach out to individual faculty. So we can certainly go from the HR director to career services, which are sort of the parallel positions at a company and in a university. But if you're a hiring manager and you go on a university website, you can see typically what courses are being taught and what's actually happening in the classroom. Reach out to the individual faculty members too. We don't bite, at least not hard. And I can tell you that faculty, certainly at the master's level and at the doctorate level, are going to be very receptive to having you come in, having a hiring manager come in and talk to the students. Come in. In fact, depending upon what your needs are and depending upon what your skill set is, we may be willing to have you come in and actually be a guest lecturer, which is, there's no better way to understand what's happening in the classroom than actually come into the classroom. So, for example, here at Kennesaw State, we have a data science class, Data Science 7900, which is our big kind of project course. And what's really fun about that course is that it's a data science project course. We have students from all over campus, so any graduate student can play, as we say. So we get students from the MBA program and from information systems. We get students from statistics and computer science and information technology and software engineering, and sometimes we even get really brave students from the humanities, and they come into the classroom and we put them into interdisciplinary teams. So we don't want a team of MBA students and a team of computer science students. We actually put them into interdisciplinary data science teams, just like they would see in the private sector, right? Just like if they would go to work for an organization like Equifax. So they'll work in these interdisciplinary teams, and then we'll have an organization actually be a sponsor of the project. So here at Kennesaw State, we've had great companies like Shaw Industries, and again, like Coca-Cola and the Home Depot come in and actually, we had Spanx recently, that was a lot of fun, actually come in and sponsor a project. And so in that context, the company comes in and they give us some de-identified data, some non-confidential data, and they'll say, here's the question that we're trying to solve, here's what we're trying to accomplish. They come in roughly once a month, and every week we meet with the students in their interdisciplinary teams. They have to extract, transport, load, clean, right? Go through all the steps, and we teach them how to actually see an analytical project through from beginning to end. And it is amazing to watch students from all of these different master's programs come together to work in this team to then solve the problem, because it's a bit like the parable of the three blind men and the elephant, right? So the MBA student sees the problem through a very different lens than the computer science student, than the data science student, than the statistics student, than the student from psychology or from the humanities. They all see a different side of the elephant. But ultimately, if they're able to come together and actually work on this project as a team, their ultimate result, their ultimate deliverable for the client is so much stronger than if you just put together a team of masters, the MBA students or computer science students or engineering students. That interdisciplinarity is so important in data science. And I think the students learn a lot of latent lessons by working in interdisciplinary teams. They learn a lot about working with each other and learning how to work with people who have studied a different discipline from their own. So anyway, that's the long, circuitous way of saying how would an organization reach out to a university. I would say that first they need to understand, what kind of talent are they looking for? Because PhD level students are going to be doing very different things than master's students and undergraduate students. And so once they kind of understand what it is that they need, then websites typically have all the information that they need, but at the very least, you should be able to reach out to the director of the school or certainly the director of the program, but don't be afraid to reach out to individual faculty as well if they're teaching something very specific in the classroom that attracts you, that's relevant to your hiring needs.
So with that, I have a couple more questions before the golf. And my last two questions will be more about advice for the student and for the employer.
Yeah.
Before I do that, I do want to hit a point, which is there's a perception from the employer side, which is it's out there, but theory is blah, blah, blah in a way, right? I need somebody to come in and do work. So I use this technology, this type of code, and I need this done. And I'm looking for people that have this and this and this talent.
Right.
So we've been there, right, as a company, where you need a specific problem being solved, and I need you to know these 3 platforms. A lot of times, the challenge that we face is that people really don't know how to communicate their skill set online in their resumes, their profiles, right? So they'll say, I'm a data scientist and I'm a researcher, and they name a few skills, right? Somebody might come out of a boot camp and just shine, right? And they just get, because most of the searches are done by keywords and things like that, it's difficult, right? So what do you think about those employers that are looking for, they might not need the full in-depth theory of a really challenging data science problem, but they do need to solve some data science problems that are, and sometimes they'll pay a lot of money for those, right? So how do you accommodate those 2 different views of, the person with the boot camp that maybe can solve those immediate problems, to the PhD that's been doing this for years, but they could solve it as well? So is there?
Right. So I would say if you're truly looking for like a hired gun, right? If you need somebody that knows Rust, or you need somebody that knows TensorFlow, right? And it's not just a 2-day boot camp. You actually need somebody who's been working in that package, in that language. Yes, you could go through the resumes, but it is difficult to discern the difference between somebody who just did the boot camp and somebody who really knows what they're doing. I think that's a great example of when you would reach out to a faculty member, right? And say, hey, I see you teach the master's level class that really emphasizes TensorFlow. Do you have any shining stars out of your class that you could recommend who might be looking for a job? We get those types of questions all the time. We get questions frequently from local companies saying, do you have any shining stars who are coming out of your class, who are going to be graduating in this next round of graduation exercises, who knows platform X? We get those questions a lot. So I would say if there's a very specific skill that you're looking for, just reach out to the faculty member that teaches that. If you want somebody who's more broad-based, that's when you go to career services.
And is that I guess, is that published anywhere where you can see? Because that would be actually a great thing for us, for an employer to see. It might not be in the person's resume, but it may be in the curriculum where you say, hey, we teach R, SAS, Python, Spark, whatever, whatever your curriculum is. Is that published anywhere for people to find it? Because if you can go after all the faculty to find out, but that would be actually a great way to. Not sure if that's something that's a thing that.
So, don't be ashamed to ask a question, right? So, reach out to the program director, reach out to the school director, whoever is in charge of the program, or if it's easy to find on the website, which some websites are easier to navigate than others, you can reach out directly to the faculty member. But definitely, again, at the master's level and at the doctorate level, being a program director typically is a full-time job, and there will be somebody who's designated with that title.
Yeah, no, that's great advice. Actually, I didn't think about that because that's a great.
Another point that I would recommend for organizations is see if there's an opportunity to sit on an advisory board. So we, here at Kennesaw State, we have advisory boards at multiple levels. Clearly the university has an advisory board, but the individual colleges have university boards, university advisory boards. And at the program level, you'll frequently find advisory boards. So I know here when we were really launching our data science initiatives, our analytics initiatives, we had an advisory board that we met with on a regular basis. And again, that's where I would ask them to bring in their job ads and tell us, again, where is the puck going? What do your employment needs look like over the next 3 to 5 years? So, having an advisory board definitely helps us, but I would argue it was also helpful for them to see what was happening inside the university, get a feel for how we think about these concepts, these disciplines like data science, and they also had insight into what we were teaching in the classroom, and it also gave them insight into who they should call if they had a particular need for a particular set of skills. So I would encourage organizations to reach out to local universities and be on the advisory board. And I think being on an advisory board is really helpful. Even if you don't end up recruiting out of that university, it gives you some insight into how universities work and how curricula is developed.
And some, I'm guessing universities are pretty open to that, to companies reaching out and say, hey, are there any opportunities in your advisory board? And interesting.
Yes.
So I know we could talk about this forever, right? I do have one final question that's more geared towards the students. So if I'm an inspired data scientist and I want to get out there, what do you recommend? How should they position themselves online in terms of experience, and what should they highlight in order to be found? What do you think, based on the employers, on your relationship with employers? How should they?
Sure, with students?
How should the students or someone that's just starting up, but they don't necessarily know how to position themselves, so they fall into this gap where I might be missing opportunities. Do you think that there is any way that they can shine a little bit better to highlight, or just a graduate from Kennesaw?
Yeah, it's a great question.
What do you think would be a good strategy for them?
So again, the unsolicited advice that I frequently give our students is never turn down an opportunity to be involved in a project. Get involved in projects. So formal projects through your curriculum, but informal projects. Certainly here in Atlanta, we have this wonderful organization, Athletics, right? Sort of data science for social good. There is no shortage of opportunities for data scientists to use their social power. There are superpowers for good. Right? And so I think it's really helpful for students to have a list of projects and things that they've actually been involved in, because those projects communicate that not only were they able to perform in the classroom, but actually they know how to take these skills, they know how to take these superpowers and actually use that to translate data into meaningful information to solve problems. And again, I think there's a lot of latent skills that you develop as a result of actually doing real projects with real data. So, things like Kaggle are great, but nothing replaces actually working with a client, working with an organization, and actually figuring out how to solve their problem through data science. And so we encourage our students to get involved in as many projects as they possibly can while they're a student, and use that to build out their resume. And that gives them very tangible things to talk about when they're sitting down in an interview. And they can talk about the things that they did well, and they can talk about the mistakes that they made and the learnings that they had. And that's just a great way to learn how to be a data scientist.
Well, I think that's great advice to anyone. Really, I mean, that really applies to any discipline, right? The more that you get involved with the real projects that prove that you can deliver. So
when they make me the benevolent dictator of education, I'm going to require that everybody has to have an internship or some kind of applied project experience as part of their 4-year degree.
I think it has been a gap for students to graduate and not have any. While they may not have work experience, that's something that you can develop on your own, right? Even if you have no job opportunities, there are projects and there are people that are willing to give you projects. So even if it's, hey, I'm just gonna reach out to companies, help out in projects, just getting that involvement, that's just gonna pay off right at the end.
Absolutely, and it doesn't even have to be a company. You can reach out to your local fire department. You can reach out to your local police department. You can reach out to really any organization, because everybody now is collecting data on everything. Right? I mean, data is ubiquitous, and so there's no shortage of opportunities for students to develop those skills.
So that closes that excuse, right? When students say, "Well, I don't have any work experience," and but they require work experience. Is like, well, you can actually build your own work experience. That's not really the catch-22. We say, well, they require 2 years. Well, I don't have 2 years of work experience, but I developed 5 projects and I helped this company do X, Y, Z. So that's wonderful. Right. Thank you so much, Dr. Priestley. This was wonderful advice. I think it has a lot of value to from all sides for the employers, the recruiters. Your book is wonderful. I recommend it to anyone, and look forward to seeing what's next in the program. Thank you so much.
Yeah, thank you.